Welcome back to the channel. Watch the video until the end, leave a like, and subscribe to the channel to support us. The so-called God particle is now followed by the Goddess particle. Yes, it's confirmed. Earth has been hit by a mysterious particle named Goddess in an exciting breakthrough in cosmic particle research. The Amaterasu particle was first identified as part of a high-energy cosmic ray. Scientists have chosen this name in honor of the Japanese sun goddess. This particle collided with Earth from space, adding a completely new dimension to astrophysics, as it represents an incredible concentration of energy. The Amaterasu particle has surprised the world of particle physics with its extraordinary energy of over 240 exaelectronvolts, setting a new record in the field of cosmology. Its discovery is not only unusual but surpasses the limits of our previous scientific understanding. To put this enormous amount of energy into context, imagine a high-speed train fully loaded traveling at maximum speed. If it suddenly transferred all its kinetic energy into a single subatomic particle, the resulting energy would be equivalent to that of the newly discovered Goddess particle. This unimaginable concentration of energy in such a small point of space poses new challenges to physics. The Amaterasu particle is particularly extraordinary for its mysterious origin, seeming to come from a region of space known as the local void, a mysterious and seemingly empty space. This discovery is pushing scientists to consider the existence of extremely energetic and unknown objects or phenomena within this void. The arrival of this particle on Earth does not have a direct and tangible impact on our planet or life here. These particles have always been part of cosmic events of which we and our planet are a part. Only now, thanks to improved technologies, can we measure particles like these for the first time. In the subatomic world, everything we see, our eyes, our hands, the computer or smartphone we're looking at, is made up of tiny particles. The microcosm, in the world of the smallest particles, is as exciting as the macrocosm, with its planets, stars, and other giant cosmic phenomena. The scientific discipline of particle physics aims to understand this micro-world by studying the particles themselves and the forces that act between them. Subatomic particles, like quarks, leptons, and bosons, are the fundamental components of matter and energy. Their interactions and connections are at the heart of the entire universe and all the forces that act within it, from the structure of atoms to gravity and radioactive radiation. Studying them will help us in the future to answer fundamental questions about the origin, structure, and ultimate fate of the universe. The recently discovered Amaterasu particle, with its enormous energy, challenges the limits of particle energy and raises questions about what processes generate so much energy and how particles with such energy can speed through space without producing any visible effect. Amaterasu is not the only particle of this kind. In 1991, a particle that scientists nicknamed the "Oh my God" particle was discovered, due to the extraordinarily high energy of 320 exaelectronvolts measured by a researcher, who exclaimed just, "Oh my God," in front of such a discovery. Although Amaterasu's 240 exaelectronvolts do not match the 1991 discovery, they are still surprising and raise questions about how many other similar particles may exist and what forces may interact with them. When we think of the sun goddess and the "Oh my God" particle, we automatically think of the God particle that made headlines in 2012, discovered by the Large Hadron Collider in Geneva. The Higgs boson is the result of a long search for the particle that gives mass to other particles through the Higgs field, discovered in the 1960s. The discovery of the Higgs boson in 2012 was a historic moment for particle physics, signaling the experimental confirmation of a fundamental theory. In addition to these extraordinary particles, there is another fascinating category of particles that come to us from space: neutrinos. Nicknamed ghost particles for their weak interaction with matter, they pass through walls and bodies in an almost invisible way. Recently, neutrinos have become famous when researchers used a new scanning technique to locate hidden rooms and passages in the Great Pyramid of Giza, demonstrating the wide range of practical applications of particle physics. The implications of the discovery of particles like Amaterasu and the "Oh my God" particle are vast and exciting, opening the door to potentially revolutionary technological advances. These extremely energetic particles could inspire new ways of generating energy, potentially revolutionizing humanity's energy supply with clean and nearly inexhaustible sources. Furthermore, the growing understanding of subatomic particles could lead to revolutionary discoveries in materials science, with the development of new materials with extraordinary properties, such as superconductors that operate at room temperature. Finally, particle physics could allow us to make significant progress in the field of medicine as well, developing new methods of treatment to combat diseases at the molecular level. The possibility of using particles for advanced communications or to create propulsion systems for spacecraft that today appear only in science fiction novels could become a reality. The Large Hadron Collider, LHC, located near the Swiss city of Geneva, is an example of how precision technology and relentless research have led to significant discoveries in the field of particle physics. Despite criticisms regarding safety and costs, the LHC has contributed enormously to our understanding of the universe, discovering fundamental particles and exploring the forces that hold matter together. In conclusion, subatomic particles, from those known like the Higgs boson to those imaginary like Amaterasu, continue to challenge and expand our limits of knowledge, suggesting that the key to understanding the universe might lie not only in the vast macrocosm but also in the mysterious microcosm of the smallest particles.